This is the screencast for section 3.1, example 5. We're going to transform exponential functions regarding the natural base e. E is a number you've probably heard of before. It's about 2.71828. I think your teachers in the past have said it's about 2.72. What e actually is, where e comes from, is this. It's the limit as x approaches infinity of the graph of 1 plus 1 over x to the x. So if you put in your calculator y equals 1 plus 1 over x to the x, and you traced all the way out till to the right where x goes to positive infinity, your y values are going to level off at 2.718281828, etc. So example 5 says, describe how to transform the graph of y equals e to the x into the graph of the given function. Sketch the graph by hand and support your answer with a grapher. Well, in order to find out how the sketch will look, we have to look at the original function y equals e to the x, which is one of your basic functions. So y equals e to the x, thinking of a couple points. Let's see, f of 0 means that would be e to the 0, which is 1, so it has the point 0, 1 on it. Another easy point to do would be f of 1. So e to the 1 would be e, so that point would be 1, well, I guess 2.72-ish. That would be an exponential growth function because the base is greater than 1. So I will have a function that crosses through the y-axis at 0, 1 and grows up to infinity. So now part A has a 2 up in the exponent with the input. So if we multiply the input by 2, that's actually a horizontal shrink by 1/2. So all these x-coordinates of these 2 points that I found are now going to be multiplied by 1/2. 0, 1 will stay there. But now instead of 1, 2.72, we'll have 1/2, 2.72. So this graph will look, ooh, that was bad. This graph will look shrunk towards the y-axis, horizontally smushed in towards the y-axis. So this will be 1/2, 2.72, and this will be 0, 1. So of course I'm going to check that with my grapher. So in my calculator I see that if I hit trace, this graph does pass through the point 0, 1. I'm also going to make sure that it passes through 0.5, yep, 2.71828, etc. h of x in part B has a negative in front of the input. So that's going to be a horizontal flip over the y-axis, which, if you remember right, that negative actually makes the reciprocal of the base. So that's like 1 over e to the x. So all those x coordinates are now going to be the opposite. So instead of, well, 0, 1 is going to stay the same because the opposite of 0 is 0. But now instead of positive 1, 2.72, it's going to be negative 1, 2.72. Which makes this an exponential decay function because my base is now the reciprocal, 1 over 2.71, and 1 over about 3 is definitely going to be less than 1, so that would be an exponential decay function anyway. So I'm going to graph that to check. Then with my calculator I can see that it passes through, my translated graph passes through the point 0, 1, as well as the point negative 1, 2.718. So my sketch is definitely accurate. Part C, the 3 is now on the outside of the function. So this is going to be a vertical change. That's going to be a vertical stretch by 3, which is going to multiply all the y coordinates by 3. So now instead of 0, 1, my graph is going to be at 0, 3. Then instead of 1, 2.72, it's actually going to be 1 times 3 times that, which is about 1, 8.15. If I'm doing that in my head correctly. So let's graph and see. Yeah, I can see from my calculator that my graph has the point 1, 8.15 in it, as well as the point 0, 3. So my translated graph is sketched correctly. The now try problem for example 5 is number 21. Same instructions, describe how to transform the graph of f into the graph of g. Sketch the graphs by hand and support your answer with a grapher. So e to the x is going to have the graph that we talked about before. So the two numbers that have changed then are a negative and a 2 in front of the input of the function. So that's going to be two different transformations. We're going to have a horizontal flip or reflection. I should probably write reflection. Reflection over the x-axis, over the y-axis. And then a horizontal shrink by 1/2. So let's see here. The point 0, 1 is going to stay the same because nothing happened to the y-coordinate. The other point though, 1, 2.72, is now going to be negative 1/2, 2.72. So that's going to be an exponential decay function. The negative made 1 over e the reciprocal, and then squaring it still produces a number that's less than 1. So it's exponential decay. And to check on my graph, I can see the point 0, 1 is there, as well as I hit trace and then negative 0.5 has a y value of 2.71 or e.